In this video, we're going to review fractions, and I know fractions aren't the easiest thing, but it is something we can't avoid. So don't try to avoid them. We just got to learn how to deal with fractions, and then they're not so bad once we know the rules. So for multiplying fractions, let's just do an example. Like, what is half of a half? So like if I drew, I don't know, pizza, pie, whatever you're feeling like, and we cut it in half, and then cut one of the halves in half, well, that would be a quarter. So when we say half of something, that of actually means multiply in math. So it's asking us what's 1/2 times 1/2. But that is the same thing as saying what's 1/2 divided into two pieces. And so that's one of the things that's tricky with fractions, is that there's different ways to phrase them. So multiplying by 1/2 is the exact same thing as dividing by 2. That's going to be one of the things that's important to us. But for now, half of a half, we can tell just by the picture is 1/4. So the rule for multiplying is to multiply across the top and across the bottom. So let's make a rule there. Multiplying fractions. So first we're going to see if we can cross cancel. That might be a new word. So we look to see if we can reduce. So I'm just going to say reduce if possible. And then we're going to multiply across the top and across the bottom. Maybe there's a lot of acrosses being used. So I'm just going to say multiply numerators, which are the top of the fractions, and then denominators. All right, so let's do an example. So first, to see if it reduces, we would look along the diagonals, and that's what cross cancel means. So for example, if 1 and 2 had a factor in common, we could reduce it before we multiply. Here we can't, so we're just going to multiply across the top, across the bottom, or multiply numerators, which would be 1 times 1, and multiply denominators, which would be 2 times 2. 1 times 1 is 1, 2 times 2 is 4. Another thing I should point out, that being good at fractions really involves knowing your times tables really well too. And I know some of us might need to work on that. So please, be proactive about, making sure you know the multiplication tables up to 10 for sure. You can use flashcards. Quizlet is a good flashcard online that you could use. There's lots of them though. All right, let's try this one. So it would not be wrong if you multiplied just across the top, across the bottom. All right, you would get 1 times 3 is 3, 3 times 5 is 15. But the problem is that fraction's not reduced. We would then need to go and say, oh, well, what goes into 3 and 15? Well, 3, we can divide by 3, divide by 3. So 3 divided by 3 is 1, 5 divided by 3 is 5. So a better way is to reduce before we multiply, especially when we have larger numbers. It's going to make it a lot easier. So let's redo the problem here. 1/3 times 3 over 5. Before I multiply, I'm going to look along the diagonals and see, well, 1 doesn't ever reduce. 1 is the lowest we go. But these 3's, 3 divided by 3 makes 1. So really what I'm doing is dividing both by 3. So 3 divided by 3 is 1, 3 divided by 3 is 1. And so now the top is just 1 times 1, and the bottom is 1 times 5, which is 1/5. So in this particular problem, it doesn't make a huge amount of difference which way you do it. But for larger numbers and in future classes, it really helps to remember to cross cancel first. So it's something we're going to try to remember to do. All right, another thing we need to be aware of is, what do we do when we have a whole number with a fraction? And the first thing you should do is write the whole number as a fraction. any whole number we can convert to a fraction by putting it over 1. Now, before I multiply this, I'm cross-canceling. 1 doesn't reduce, but 2 goes into 8. So I'm going to divide by 2, divide by 2. All right, so all we're doing is reducing the fraction before we do the multiplication. 1 times 1 makes 1, 1 times 4 makes 4. So there's a couple things that we did there, right? Putting the whole number over 1 and then reducing before we multiply. All right, let's try dividing fractions, because as we saw in this first example, dividing a fraction is the same as a multiplication. And so that's always what we're going to be doing. When we're dividing fractions, and one way I've learned how to teach it is keep, change, flip. But there are other ways that, there are other ways you might have learned in your past math classes. But what that means is we're going to keep the first fraction. We don't change the first fraction. We're going to change to multiplication and then flip the second fraction. And that flip is what we call the reciprocal. Or you can even call it the refliprical. I'm not good at pronouncing it, but that's what a reciprocal is. And it flips a fraction over. So let's try that. Negative 3/4 divided by 3/2. So I'm going to keep the first fraction, negative 3/4. One thing, here's a good time to talk about this, is what to do with that negative. You should always view the negative as just going with the top number. That's the way WebWorks going to want you to type it. And we definitely don't want to make both the top and the bottom negative, because if you make them both negative, they would cancel and it become a negative divided by a negative is a positive. So if you see a negative out front, just move it up to the top. Then instead of division, I'm going to change to multiply by the reciprocal. So instead of divide by 3/2, I'm multiplying by 2/3. That's what we call the reciprocal, flipping over the fraction. Once we've written it as a multiplication, now we go back up and do our multiplication steps. Reduce if we can, and then multiply numerators and denominators. So let's reduce. Let's see what we can do. We look along the diagonals. So along this diagonal, I can divide by 3. So 3 divided by 3 is 1. Negative 3 divided by 3 is negative 1. Along this diagonal, I can divide by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. It looks messy, but it simplifies the multiplication and the simplification later a lot. So what we've done is change it to negative 1 times 1 in the top, after we do the division, and then 2 times 1 in the bottom. So that'd be negative 1/2. So we're just adding steps to what we were doing before, in that a division has to be written as a multiplication. So let's do this second one the same way. I see a division, so I'm going to write it as a multiplication. So keep the first fraction, change to multiplication, and then when I flip this, I'm putting the negative with the top number. All right, so we're flipping it to 16/9. The negative goes with the top. And now I'm going to reduce. 11 is prime, so nothing's going to divide into 11 and 9. But we can divide by 16 on this diagonal. And this is one of those examples where it makes a big difference, because I don't know what 11 times 16 is. That's a whole mess. But if I reduce this, I have 16 divided by 16 is 1. Negative 16 divided by 16 is negative 1. Then it's just 11 times negative 1 is negative 11 in the top. And 1 times 9 is 9. It makes it just a lot easier to do that cross-canceling as a first step, rather than waiting till the end to reduce your fractions. Great. All right. Well, so that's multiplying and dividing. Let's see if we can add and subtract. So adding and subtracting is actually harder than multiplying and dividing with fractions. All right, with whole numbers, we don't usually think of it like that. Like, you know, when we're little kids, the first thing we learn how to do is add and subtract after we learn how to count. But with fractions, it has to have common denominators. So what that means is the bottoms of the fraction have to match in order to add or subtract. So we, let's just say, get the denominators the same before you add or subtract. And the way we get the denominators the same is to multiply the top and the bottom by the same number. So multiply the top, the numerator, and the denominator by the same value. So let's do an example, just see how this goes. So right now, 1/2 plus 2/3, I cannot add those numbers. They are not the same kind of fraction. We could even do it by, making a picture. Maybe that's a good way to do it. So if I have 1/2 of a pizza, and then I cut this pizza into thirds, and I'm gonna add 2/3 of it, there's not like a good way just to say, well, what's the result? I can look at this and maybe know that it's more than one pizza, but like it's one and then how much? And it's not necessarily clear. And that's why we have to get them to be out of the same number of slices, basically. That's what we're saying, is if we're counting slices of pizza, we need to cut the two pizzas the same way. All right, so with the first fraction, well, before I deal with just the first fraction, I need to decide what common denominator to use. Sometimes it's called the LCD, if we've heard that. That stands for least common denominator. It turns out we just need a common denominator, but we should strive to make it the smallest number possible. And what that means, it's the smallest number that both 2 and 3 go into. So for 2 and 3, the least common denominator is 6, because 2 divides into 6, 3 divides into 6, they both work. But there are other common denominators. I could have used 60. Both 2 and 3 go into 60, but it's best if you make it the smallest number that both those numbers go into. So what we're saying is we're going to cut both of these pizzas into 6 slices instead of one of them into 2 slices and the other into 3. So what that means is it's like I'm cutting, that looks like, is that 6? Yeah, it's not very even, but yeah, it is. And then I cut this one into 6. All right, that my pictures have just failed, but that's the idea. Let's actually do it with the algebra instead of with the pizzas. So I'm gonna take the first fraction, 1/2, and I know I'm trying to get to 6. So I'm gonna multiply the 2 by 3. And whatever I multiply the bottom by, I also have to multiply the top. And then we do the same thing, 2/3. I'm trying to get the bottom to be a 6. So I have to multiply the bottom by 2, so then I also multiply the top by 2. So what I get then is 3/6 plus 4/6. One thing I want to note at this point is that 3/6 is the same as 1/2, right? Like if I reduce that, I'd get right back to 1/2. And 4/6 is the same as 2/3. We've just sort of redesigned these fractions so that the bottoms match. And then our answer is 7/6. In algebra, we should not use mixed numbers. I don't want, you can think in terms of like this is 1 and 1/6, but really improper fractions are always better in algebra. So we're just gonna leave it 7/6. All right, that was a lot, but hopefully that's a good review for how to do that. Let's do part B. If the denominators already match, this is an easy problem. I'm just going to do 18 minus 7 and then divide by 11. So that would be 11 divided by 11. Ooh, what's 11 divided by 11? That's just 1. All right, let's try this next one. 3 negative 3/8. I'm going to put the negative up on the top. But minus a negative changes that to a plus 1/2. Now, we want to find the least common denominator. Now, one thing you might have noticed is that 6 just happens to be 2 times 3. One option is you could just do 8 times 2 and get 16. That is a common denominator, but it's not the least common denominator. The least common denominator is the smallest number that both 8 and 2 would go into. In this case, it's 8. And that's because 2 goes into the other number. Divides, I should say goes, divides 8. So I don't need to multiply. If 2 divides into 8 evenly, then we can just use 8. And that way I don't even have to change the first fraction. So the first fraction is going to stay negative 3/8. And then the second fraction, I need to get the bottom to be 4. So I'm going to, I need the bottom to be 8. So I'm going to multiply by 4 on top and bottom. So it's negative 3/8 plus 4/8. And now that we have the denominators matching, now we just do the top. Negative 3 plus 4 is 1. All right, so try this one on your own. See how you do getting a common denominator. And in the next video, we'll go over it together to make sure it worked out.